Hey, this is Scott. Welcome back to my YouTube channel where I cover a variety of different topics, everything from conceptual and methodology all the way to little coding. So we'll look at a little coding today. Some recursive program in R, right? A very simple recursive program to illustrate the Towers of Hanoi um, recursion. So what is the Towers of Hanoi? Essentially, it's a very simple game where you have three pegs here. This illustrates several different moves, but in the very beginning, you have um, three, whoops, three pegs, right? One, two, three. And what you do is you start out with a number of discs. So in this illustration, we start out with four discs, one, two, three, four. And then what you have to do to play the game is you move the disc. The goal is to move all four of these over to this peg in the same format from small at the top to large at the bottom. And when you move these things, you can never place a larger disc on top of a smaller disc. So what that means is that as you go through, we start here and we have four discs. The first move will be right here. We're going to move this very small disc to the second peg, and then we're going to third move right here. We're going to move this uh, second disc off of this first peg over to the third peg. Then we're going to pick up, in this move, we're going to pick up this small disc and we're going to put it on top, and etc. So again, you can see here what we're doing is the goal is way down here at the bottom is to make this thing right here, move it all the way over without ever putting a larger disc on top of a smaller disc. So what does this look like in R? Well, one of the things that we can do, you can imagine programming this thing and it would take a lot of code except for the power of recursion. So we're going to create this function called Hanoi Move. And so this is a function with four variables here. And then I'm going to pass the number of disks to the program. We're going to start with 1, and then we're going to create this output move disk from to, and so we're going to do that. And so this is the initial if statement, but you can see here that we're calling inside this function, we're calling the function itself. And so again, we move indisk -1 from via to, and anyway, so let's just run it rather than try to belabor it. If you play with this, it's very simple to type in. You can play with it. So let's move the four disks. And by the way, if we counted this with four disks, if you were to count the number of moves, 1, 2, 3, 4, 5, 6, 7, 8, and then 8 on this side, it takes 16 moves to move this over. So now I'm going to call this function, and I'm going to start from one peg, but with four disks, and you can see here's the output. So it took this basically, if you looked at the PowerPoint, this is going to be the same moves. I'm going to move this from 1 to 3, 1 to 2, 3 to 2. Then I'm going to move disk 1 to 3, etc. And if we were to pull it up side by side, it would basically match what we had just gone through. And then mathematically, the number of move it takes to complete this is 2 to the number of disks. So 2 to the 4th is 16, which we verified a minute ago. The interesting thing is that it takes a lot of, it goes, of course, very large very quickly. 2 to the 8th, that's 256. And then if we were to run that, there's all 256 moves. And so this obviously is an exponential problem. And the whole thing was, this was the legend has it that monks were doing this, and they said that they would move one disc per day, and whenever they moved 64 discs from the first peg to the third peg, the world would end. So here's the math behind that. The number of days it would take before the world ends, and it is 1.8 times 10 to the 19th, which is a very, very big number. We've got some time. So I hope you enjoyed this and enjoy.